Hi there, I'm Mrs. Edwards, and today we're going to solve some quadratics. To solve a quadratic, we want to start by having the quadratic written in the form ax squared plus bx plus c equals 0. If the original equation is not equal to 0, you want to keep moving things over to the same side until it is. To solve these quadratics, we're going to use three different methods. We're going to use the zero property, we're going to use the quadratic formula, and then we're also going to look at how we would do this on a graphing calculator. Let's start with method 1, the zero property. To use the zero property, the first thing we want to do is factor. So I'm going to factor this quadratic. If you do not know how to factor, you might want to take a look at some of my factoring videos. But I'm going to jump right to the factored form. That's going to be 2x plus 5 multiplied by x plus 1. Once you have this factored, you then set each piece equal to 0. So in this case, 2x plus 5 equals 0, and x plus 1 equals 0. Then we'll solve each mini equation. Here we'll want to subtract 5, divide by 2, and x is going to equal negative 5 over 2. And here we'll subtract 1, so x is going to equal negative 1. Both of these solutions make the original equation true. Now we're going to solve this same quadratic equation using the quadratic formula. The best part about the quadratic formula is that this method always works. I went ahead and written the quadratic formula here for you. It's really important that you have the quadratic formula memorized. There are many cool ways to memorize the formula out there, but here are just a couple of my favorite. Despite the fact that I have a horrible voice, I will go ahead and bless you with it. All right, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Then the other way that you can memorize it is by a ridiculous story. The ridiculous story goes something like this. There was a negative boy. He couldn't make up his mind, plus or minus, about going to a radical party. Radical. When he walked in, he saw a real square bear leaving with 4 awesome chicks. When it was all over, he said, that party was totally awesome. Okay, so however you want to memorize it, you're going to always start by identifying the A, the B, and the C in the formula. So in this particular one, 2 is our A, so I'm going to write A equals 2, B equals 7, and C equals 5. Next, I'm just going to substitute my values. So the x is going to equal the opposite of b, so negative 7, plus or minus the square root of b squared, 7 squared, minus 4ac all over 2a. Next, I just want to start simplifying. Negative 7 plus or minus 7 times 7 is 49. Negative 4 times positive 2 times 5 is going to be negative 40 all over 4. Then we have negative 7 plus or minus. I'm going to do a couple steps at the same time. 49 minus 40 is 9, and we have the square root of 9. And the square root of 9 is 3 all over 4. The plus or minus really means that we have two answers. So I'm going to do each one of them separately. I need to do the problem with negative 7 plus 3 over 4. And I need to do the problem with negative 7 minus 3 over 4. Negative 7 plus 3 is negative 4. And negative 4 divided by negative 4 is negative 1. Negative 7 minus 3 is negative 10 over 4. Both of these numbers are divisible by 2, so we get negative 5 over 2. Notice when factoring and when using the quadratic formula, we ended up getting the same answers. Now we're going to use method 3, graphing calculator, to solve 2x squared plus 7x plus 5 equals 0. When you want to use the graphing calculator to solve an equation, you want to first make sure that all of the terms are on the same side of the equal sign. In this particular case, that is already true. So the next thing that you want to do is replace the 0 with the y. In doing that, what we've really done is we let the y equal 0. To find the answer to this equation, our job is to really find the points on the graph, and all points on the graph are coordinates x, comma, y. So we want to find the points on the graph such that our y values are 0. All points on a graph that are in the form x, comma, 0. Let's just think of a few. 4, comma, 0, 5, comma, 0, 6, comma, 0. All of those points are located on the x-axis. So we are really going to be looking for the x-intercepts. Next, we're going to graph the equation. So we're going to need to use a graphing calculator at this point. I'm going to go to Desmos.com for my graphing calculator. Before heading over to Desmos.com, I thought I'd show you my calculators. If you're in the market to purchase a calculator, I would highly recommend buying one of these two calculators. These are the most powerful calculators on the market that are both still allowed on standardized exams. These two calculators are both very popular. When learning a graphing calculator, it's very time-consuming and takes a lot of practice. The nice thing about using a calculator that's used by a lot of people is you will find a lot of YouTube videos out there on how to do something if you get stuck. If you already own a graphing calculator, you probably want to just use that one. Graphing calculators are so expensive, but when going out to buy a new calculator and you're spending $100 or more, spending an extra $10 to get all the bells and whistles is definitely worth it. If you're in my pre-calculus class this year, then using Desmos.com will definitely get you by. It will be extremely important that you do buy a graphing calculator for AP Calculus, as you will need it for the AP exam. Although Desmos.com will get you by, and you will for sure be just fine while in this class, there is value in getting one of these graphing calculators early and starting to use it, because there is a steep learning curve to figuring out a new calculator. Having your calculator already mastered when you walk into calculus is a huge advantage.
When you go to Desmos.com, this is what it's going to look like. I'm going to select Graphing Calculator in blue. When you select the graphing calculator, your screen will look like this. Now you're going to type the equation in the rectangle next to the blue square in the top left corner. Remember, you replaced the 0 with a y. To type this equation, you'll use the keypad at the bottom. You will type y equals 2x to the second power plus 7x plus 5. As soon as you have typed the equation, the parabola will appear. I would like the graph to be a little bit bolder for you so that it's easier to see. So I'm going to use this wrench over here. When I've selected the wrench, a drop-down menu is going to appear, and I'm going to select projector mode. Notice everything just got a little bolder, a little brighter. Now I'm just going to click anywhere on the graph, and then the drop-down menu is going to disappear. To find the solutions to 2x squared plus 7x plus 5 equals 0, we need the x-intercepts. On Desmos, sometimes the x-intercepts are already highlighted in gray. If they're not, you just want to click the spot where the x-intercepts would be. If the gray dots are already there, you just click on the gray dots. When you click on the gray dots, they turn black and the coordinates of the x-intercepts appear. Remember, we're solving 2x squared plus 7x plus 5 equals 0. Graphing this equation is just a technique. The answer is not the coordinate negative 2.5 comma 0 and negative 1 comma 0. It's only the x of the x-intercepts that are my solution. It's the number that we can substitute back into this equation and make it true. So the final answer is x equals negative 2.5 and x equals negative 1. Your teacher cannot see the work that you did on your graphing calculator. So to make sure that it doesn't look like you just copied the answer out of the back of the book, you want to make just a quick sketch of the graph that you see on your graphing calculator, and that will suffice as some work. Notice I've sketched just the x and y axis, the location of the parabola, and highlighted the x-intercepts. Here's just a quick comparison of the answers we got when we used the zero property and the quadratic equation. Notice the answers when using the zero property and the quadratic equation look slightly different than what we got when graphing. But negative 2.5 and negative 5/2 are equal to each other. If you were to take negative 5 and divide it by 2, you would get negative 2.5. So both of these answers are correct. When checking with the back of the book, know that the back of the book might have an equivalent answer. So don't doubt yourself just because your answer doesn't look exactly the same. The strength of the graphing calculator method is how fast it is, but it does have a weakness. Sometimes when you're looking at the x-intercepts the graphing calculator is giving you, they are just rounded versions of an irrational number. So square root of 2 would show up as a rounded number, and we may not be able to use that if the answer you're looking for is an exact value.